From the choices given below, choose the equations whose graphs are given in figure 4.6. So here I have a line which is given to me, and remember that every line is represented by an equation. In this line, the equation is not given, but 3 points on it are given. This is point, say P, Q, and say R. So we have 3 points on this line. So one point is -1, 1. The other point, say Q, which is origin, 0, 0, or we'll write it as O. And the other point, say R, is 1, -1. Now I have to find the equation of this line. Let me check first if y equal to x is the equation of this line. Now how do I check? Now y equal to x. Let me take up point P. For point P, x equal to -1 and y equal to 1. Let me put the values in C. Y is 1 and x is -1. Are they equal? No, they are not equal. So that means this is not the solution, or this is not the equation of that graph. Now let's check for the second. Let us check for x plus y equal to 0. We'll check for the first point. In the first point P, we have x equal to -1, y equal to plus 1. Put the left hand side and right hand side. So x I put -1, y I put +1, and that comes as 0. And we know 0 is equal to 0. So it satisfies the first point. Let us see if it satisfies the second point. Now for the second point here, we have x equal to 0, y equal to 0. So x plus y equal to 0. X is 0, y is 0, 0 equal to 0. Yes, it satisfies the second. And if you look up for the third, it satisfies the third too. So the point P, Q, and R, P, O, and R, we call this point O, all satisfy the equation x plus y equal to 0. So this equation must be x plus y equal to 0. If you check for third and fourth, you will see it does not satisfy the equation. Let's check for third. Y equal to 2x. We will check for P. For P, we know x is -1, y is +1. Let's put the value. So y is +1 and this is -1. So on one side we get +1, other side we get -2. This is not equal. So this is not the equation. And even if you check for the fourth, you will find it is not the equation. So remember, if a point has to lie on a particular line, it satisfies that equation. It is a solution of that equation. If we put the x and y value in that equation, the left hand side becomes equal to the right hand side. Now here the similar kinds of question. We have a line. This is the line, and there are 3 points on this line. Point 1, 2, and 3. Just like the earlier one, we will name those points. Say one point is A, and this point is -1, 3. Then we have point, say B. It is 0, 2, and we point C. It is 2, 0. We have to find which is the equation of this line. So let us check for the first one. For the first one, the equation is y equal to x plus 2. We will check for point A. Now in point A, we have seen that x is -1 and y is 3. Let us put the value. So y was 3 and the x was here -1, and this is +2. So we got 3 here, we got 1 here. Is it equal? It is not equal. So this doesn't satisfy. We need to cancel it out. Next, second, we are going to try for y equal to x minus 2. We'll start with A. For A, x is -1, y is 3. So for x, I will put -1. For y, I'll put 3. We know y is 3. And for x, I'll put -1. And this is -2. So this is 3 and -3. Is it equal? No, it's not equal. So here this also we reject. Let's now C for the third one. For the third one, we have y equal to minus x plus 2. So we are checking for A, and for A we know our x is minus 1, y is 3. So let's check up. For y we'll put 3, and for x is minus of minus 1 plus 2. So this is 3 and this is 3. Oh yes, it is equal. So if it's equal for 1, let's check for the rest. Let us check for B and also for C. Now we check for B. For B the point is 0, 2. So x 0, y 2. We are going to check for y equal to minus x plus 2. So we know this is y is 2 and this is minus of x. X is 0 plus 2. So this is 2 here and this is 2 here. Yes, it is equal. And now we'll check for the last one. The point C. Point C is 2, 0. So x equal to 2, y equal to 0, and we are checking for y equal to minus x plus 2. So y is 0, minus of x. X is 2, minus of 2 plus 2. So this is minus 2 plus 2, 0 equal to 0. So yes, it satisfies. So this is the right answer. This is wrong. If work done by a body on application of a constant force is directly proportional to the distance traveled by the body, express this in the form of an equation in two variables and draw the graph of the same by taking the constant force as 5 units. So the first part tells us work done by a constant force is directly proportional to distance. So let me write that out first. So I have work is directly proportional to distance. This is what they are saying. Now in maths, when we have work and the proportional sign we make into equal, we always introduce a constant. This would be distance. And now in this case it's a constant force, so work equal to this constant. They said it is a force, so force into distance, and they've given the force as 5 units here. So we have work equal to, this is 5, the force is given as 5, and distance. So now we have to make this equation. We will take, let us take the work as x, let us take work as x units and distance as y units. So now we will get work equal to 5 into distance. That means W equal to, not W, we took work as x, so we're going to take x equal to 5, and we took distance as y. So this is our equation, and we need to plot this equation, x equal to 5y. So for x equal to 5y, it is easy to get these points. So we'll just take 3 points we require, and I'm going to do this orally now, x and y. If I take x as 1, you will notice if I take y as 1, your x will be 5. Now put y as 2, put in the equation y equal to 2, and you see what you get your x as, 10. Y put as, say, 3, and your x will be 15. Now there's another important point here. Look at the points in x. We just require 1, 2, 3, which are all on the graph, and it's quite simple. But when it comes to x, we require 5, 10, 15, 20, 25. So on the x-axis we may need to make some changes. Instead of taking 1, 2, 3, which are too small, we are going to take 5, 10, 15, 20, 25, 30, here minus 5, minus 10, minus 15, minus 20, minus 25, minus 30. We have taken work on this axis. X is taken as work on this axis, and we have taken distance as y, so we write distance out here. Let's go ahead and plot these points. So first point is x5 y1, so x5 y1 will be out here, x10 y2 will be here, x15 y3 here, and then we join the points. So this is our line. Let's write the points out. This point was 5, 1. This point was 10, 2. And this point was 15, 3. Next part from the graph, we have to see from the graph, the work done when the distance traveled is 2 units. So for distance equal to 2 units, I need to find how much of work is done from the graph. So let's go back and see how we do that. So remember, we want the distance was given as 2 units. We need to find how much of work. Now distance is taken on the y-axis, so 2 units distance would be here. So we're now going to find where is the work. We go up here at this point, and then here we come down. This will give us the work. So the work here is 10 units. And the next part, they said for distance equal to 0, how much is the work? So remember, our distance is on the y-axis and distance equal to 0 is out here. And you see the work is also 0 units. So this is how you read your graph. Remember, again I'm repeating it, distance was on the y-axis, so you go on the y-axis and you see the corresponding value on the x-axis. Just to explain some more, suppose they asked you for distance equal to 4 units, what would be the work? So how would you go? Now you know distance is on the y-axis, so look out for in the y-axis 4 units. 4 units is here on the y-axis. Now go straight up to the graph. So here is the point, right? And you will go straight down. Of course my graph is not very straight, it's not very proper. You draw a proper graph with your scale, and then you go down here, you'll come exactly at 20. So for distance 4 units, your work equal to 20 units. Yamini and Fatima, 2 students of class 9th of a school, together contribute rupees 100 towards the Prime Minister's Relief Fund to help earthquake victims. Write a linear equation which satisfies this data. You may take the contributions as x and y. So we take Yamini's contribution as x rupees, and Fatima's contribution is y rupees. Now it's given both of them together contribute 100, which means Yamini plus Fatima equal to 100. So x plus y equal to 100. This is our equation, and we need to find the points. Now to find these points, you can do it orally. You don't need to substitute. And so this is x and y. Suppose I take x say 10. Now you know x plus y should be 100. So if x is 10, you definitely agree y has to be 90. If I take, say, x as 20, your y has to be 80. If I take x as 40, the y has to be 60. If I take, say, y as 20, the x has to be 80. So these are my points which I can do orally. X plus y, if you add up, it should always get 100. This is 100, correct? This is 100, this is 100, and this also is 100. Now we go ahead and plot these points. Now if you look very carefully at the points we need to plot, they are 10, 20, 30, 40, 90, 80, 100. And the graph here is 1, 2, 3, which will not suit. So what we are going to do is change the graph to here 10, 20, take 30, 40, 50 on both the sides. Here also 10, 20, 30. We took x as Fatima's contribution and y as Yamini's. So we got to write here, this is our x-axis. So we got to write here Fatima contribution and here Yamini's contribution. We go ahead and plot. The first point is 10, x is 10, y is 90. So x 10, y 90 would be here. Next is x 20, y 80. It would be here. Then 40, 60. 40, 60 here. 80, 20. 80, 20 here. Now we go and join the line, the points. So here is a graph. And the name of the equation of this graph is x plus y equal to 100. If on this graph you take any value of x and any value of y, x and y value of any point, if you add up it will be 100. My graph of course is not exactly a straight line because I couldn't use a scale here, but if you use a scale, take anywhere your x and y, you will find if you add up you will get 100. Like let me give you one example. Suppose you take this point here. This point here is 30 and 70. Add up, it will become 100. Here when you write a scale, for the x-axis, you see 1 unit you have taken as rupees 10, and for the y-axis, 1 unit you will also have taken as 10 rupees. In a country like the USA and Canada, temperature is measured in Fahrenheit, whereas in countries like India, it is measured in Celsius. Here is a linear equation that converts Fahrenheit into Celsius. So here they've given like 1 Fahrenheit is 9 over 5 into Celsius plus 32. It's just like what we did for Kelvin. Kelvin was Celsius plus 273. That this equation gave us a relationship between Kelvin and Celsius. Here we have a relationship between Fahrenheit and Celsius. So we need to draw this graph. Now while drawing this graph they said take the Celsius on the x-axis. So we take Celsius as x and Fahrenheit on the y-axis, and we take Fahrenheit on the y-axis. So my equation now, which is F equal to 9 by 5C plus 32. Now remember, wherever there is Fahrenheit, I put y. So y equal to 9 by 5x plus 32. And I need to draw this graph. Now this seems to be a little complicated, but there is a little trick here. Now here you have 5, right? So what I will do, x first I will take 0. Now see what happens when I take x equal to 0. So y equal to 9 over 5. X I have taken 0 plus 32. So y equal to 0 plus 32. So y equal to 32. So one point I got, x and y. If x I take 0, your y comes 32. Now for our next one, again I have y equal to 9 by 5x plus 32. Now to make things a little convenient, what I'm going to do is I'm going to take the x as 5, and you'll understand why I take as 5. So now you get y equal to 9 by 5, x I will take 5, so here plus 32. So y equal to 5 I cancel, 9 plus 32, and y equal to 32 plus 9, which is now 41. So my next point is, if x is 5, your y will be 41. Next I'm going to take again y equal to 9 by 5x plus 32. Let me take now x equal to minus 1. So y minus 5. So 9 over 5 minus 5 plus 32. So this will be y equal to minus 9 plus 32. And in this case you will have your y equal to 23. So the x, if I take as minus 5, your y becomes 23. Now let's go ahead and plot these points. So we go ahead and plot these points. Now let's write the x's. X-axis we know is Celsius, so we put Celsius here, and the y-axis is the Fahrenheit. So first point is 0.32, and 0.32 will be somewhere here, 0.32. Just rub this out, we'll write it later. 541. So plus 5 and 41 would be somewhere here. Then minus 5, 23. X minus 5, y 23. So that would be somewhere here. Here's my line. My line is really not straight because I can't use a ruler on this iPad of mine. It doesn't come proper. So this is the line of the equation. Here was Fahrenheit. What is interesting is this point here. If you look at this point, it is minus 40 minus 40. X is minus 40, y is minus 40. So at this point here, the value of Fahrenheit and Celsius is the same, x and y. X is equal to y, and the Celsius is equal to Fahrenheit. You need to write a scale too. And in this, by now you know how to write a scale. In the x-axis, 1 unit equal to 10 Celsius, and y-axis 1 unit equal to 10 Fahrenheit. Let's answer the other questions here. If the temperature is 30 degrees Fahrenheit, what is the temperature? 30 degrees Celsius, what is the temperature in Fahrenheit? So the second one. If the temperature is 30 degrees Celsius, so Celsius is 30 degrees, and Celsius we have taken as x, so x is 30 degrees. So let's put in the equation. This is our equation. Y equal to 9 by 5 x plus 32. So y equal to 9 by 5, the x I am putting is 30 plus 32. So the answer will be y equal to 9 into 6 plus 32. So y will be 54 plus 32, and your y will be 86 Fahrenheit. So 30 degrees Celsius is equal to 86 degree Fahrenheit. If the temperature is 95 Fahrenheit, what is the temperature in Celsius? So for the third, Fahrenheit, 95 degree Fahrenheit equal to how much Celsius? We have taken the Fahrenheit as y, so y is 95. So we know our equation was Fahrenheit equal to 9 by 5 Celsius plus 32. And need to substitute, so we have 95, equal to 9c over 5 plus 32. So our 95 will be equal to 9c plus, take the LCM as 5. So that is 160, then we cross multiply, and here we have 95 into 5 equal to 9c plus 160. 475 equal to 9 Celsius plus 160. So 475 minus 160 equal to 9c. So this is 315 equal to 9c. So c is 315 over 9, and the answer is 35 degrees Celsius. So 95 degree Fahrenheit equal to 35 degree Celsius. Next, if the temperature is 0 degrees Celsius, what is the temperature in Fahrenheit? And if the temperature is 0 degrees Fahrenheit, what is the temperature in Celsius? So we want to know 0 degrees Fahrenheit is how much Celsius. So Fahrenheit is 9 by 5 Celsius plus 32. Fahrenheit we take 0, 9 by 5 Celsius 32. So we take 32 on this side, so it becomes minus 32 is 9c over 5. Cross multiply, minus 32 into 5 over 9 equal to Celsius. So this is minus 160 by 9 equal to Celsius, which is minus 17.777, it goes on, equal to Celsius. So 0 degrees Fahrenheit equal to minus 17.7 degrees Celsius. Now we need to find 0 degrees Celsius is how many Fahrenheit. Again same, Fahrenheit 9 by 2 Celsius plus 32. We need to find the Fahrenheit. 9 by 2 Celsius is 0 plus 32. So Fahrenheit is 0 plus 32, and Fahrenheit equal to 32. So 0 degrees Celsius is 32 degree Fahrenheit. Is there a temperature in which numerically equal, the Fahrenheit and Celsius is numerically equal? And we saw it in the graph. Have you seen here? We've seen in the graph where at 40 the Celsius was equal to the Fahrenheit. And maybe we could work it out. We want Fahrenheit equal to Celsius, say equal to x. Equation is Fahrenheit 9 by 5 Celsius plus 32. So I'll put x here, you can put a here, whichever you want. 9 by 5, I put x here also because both should be equal. So here I get x equal to 9x plus LCM is 5, and this is now 160. So I have cross multiply, 5x equal to 9x plus 160. I take the 9x on this side, so I get 5x minus 9x equal to 160 minus 4x equal to 160, and your x equal to 160 over minus 4. So x equal to minus 40. So minus 40 degrees Celsius equal to minus 40 degrees Fahrenheit.